today just by bringing up the syllabus and making sure that everybody has successfully seen it on Blackboard. Were you all able to access this and take a look at it? So just reminder of some of the basics. My office is in ECA 383. Office hours, Monday, Tuesday, and Wednesday. And again, Mark has office hours that I wrote down on Monday. They were Tuesday and Thursday from 11:30 to 1. So he's available for you. And Marissa, have you decided yet, or still to be TBD for your office hours for tutoring? Okay, okay, cool. I'll keep harassing you about it, and you just keep telling me we'll know soon. Okay. So as far as the textbook goes, has everybody figured out how that works? So you've got the bundle available, or you could just get the access code online, which will get you an online version of the text. Mm-hmm.
I followed the link to get the online version of text, but they said it wasn't available.
Okay. Did anybody else have that problem? No? We'll talk. Send me an email. All right. Blackboard isn't loading, so I can't show you the things I wanted to show you. It's giving me a really weird error message with lots of crazy numbers. But just a reminder, Blackboard is where you're going to see everything as far as assignments. It's where I'm posting class videos on YouTube. Did anybody watch Mondays? Yeah? Yay. That was really exciting for me. Success. So just a reminder, the videos are there not to prevent you from coming to class. Attendance is required. The videos are there because, I don't know, at least in my experience, right? I can sit in a class, listen to what's going on, feel really solid, 80, 90% understanding of what happened when I leave the room. And then 6 hours later, it's a little bit less. And by the next morning, it's maybe about 50% recollection and understanding, and oh no, what just happened, right? So the videos are there for you to be able to go back and watch again and remind yourself and reobtain that beautiful understanding that you get during class. Take more detailed notes as you need and that kind of thing. So that's what the videos are for, okay? Graphing calculator, did we have success? Yeah? Oh, I heard one no. Where'd the no? Okay, 2 no's. Okay, so we're gonna have to, we'll figure that out. That's usually my first suggestion. Okay, well, okay. So we'll deal with that on an individual basis, and we'll start using that in class soon. All right, so attendance is mandatory. I'll be taking attendance. Homework. That was good. I already got some emails about homework, so hopefully you see I check my email entirely too often. I really am working on getting a life, but it hasn't happened yet. So I am always attached to my computer. So if you have questions, email me. Some of you have already experienced the relatively quick replies. As far as recitation, my apologies. Some of you had already started to walk out of class on Monday when I announced no recitation this week. So there's no recitation this week. Sorry if you showed up on Monday at noon and figured that out the hard way. But just to give you a feel for what's going down in recitation, that's where you're going to be taking your quizzes. During test weeks, you won't have recitation, or at most we will have sort of like a review opportunity, okay? Tests will be taken in the math department testing center. Does that sound like a scary thing, or do you guys have familiarity with that? Okay, so some people are shaking their heads yes, some people no. So that's going to be in PSA 21. It's in the basement. The directions are here. You're going to want to make sure that you show up between 10:30 and 6:30. You can take as long as you need, right? So show up earlier. Give yourself as much time as you want. And that will be good. Make sure you have your ID card with you. Alrighty. Pretty standard breakdown for your grades. So, yep, there you go. And important dates are here. I'm still waiting for confirmation on these test dates from the testing center, but I don't foresee it being a big problem. But I'll let you know if anything has to change there. All right. Any questions? I feel like it's a fairly standard syllabus, but I wanted to give you the opportunity just in case there was any cause for concern. No? Okay. How are we doing on the email list? Are they still making? Okay, so we're almost there. Great. Alrighty. You have homework for me, I believe. I hope. So if you could take your paper, fold it hot dog style. Yeah. Okay. No? Yep. Long ways. So the long edge, foot long, and put it so that the fold is on the left. Write your name. Do you need the course code on there too? Are you grading for other classes? Name and date. Okay. Put your name and date in the top. First 5 pages. And so if you could, let's see, pass them towards the center. That would be great. So this will be the routine. Every day you have homework, you're going to do this. So starting Friday, I guess, don't wait for these directions, just go ahead and do that. Okay, so you had reading and reflection that you had to do today. So, oh, thank you. Oh, we're still having them. Thank you. So, how are we going to start? We're going to start by seeing what you took from it. So, if you could pull out a piece of paper and answer the following questions. I'm going to take roll while you're finishing up your thoughts, okay? Anthony? Kelsar? Kaiser, sorry. Wow. Rudger?
Here.
Adam?
Here.
Jan? Ankita? Elena? Yumeng? Tyler? Bethany? Teddy? Payun? George? Taylor?
Here.
Annabelle? Moises?
Here.
Daniel? Jessica? Kyle?
Here.
Sarah? Taylor? Alexis? McLean? Matthew?
Here.
Lauren? Penny? Taylor? Scott?
Here.
Ryan?
Here.
David? Horacio? Frank? We said Adidas, right? Where'd you go? No? Shelly? Eiley? David? Justin? Anna? Nathan? Jonathan? Darren? Ruby? Another Taylor?
Here.
Philip?
Here.
Miranda? Renee? Dakota?
Here.
Riche? Is that right? Okay. Jessica?
Here.
Madeline? Ashley? Joseph?
Here.
Caesar? Harrison? Naeli? Did I do that right? Yes. Courtney? Jaffu? Yeah. Okay. Maxwell?
Here.
Kadia? Christopher? Okay. All right. So what do you say?
Did you call two dates for attendance?
I probably did.
Which one is first?
Talk to me after class. We'll figure it out. Okay. All right. 2 and 4? So, what? Subtraction and division. Okay, why subtraction? What does that represent? The difference, the change? Were you going to say something else? No? Okay. An example? Yeah? Yeah, that's a change, right? And so you could represent that change as a difference, right? Okay. What about division? What's the big takeaway for division? Rate of change. A comparison? But isn't a difference a comparison? Okay. Can you say more? A ratio? What does that mean? How two quantities change together.
To tell, for example, what part of quantity B does quantity A make up?
What part of quantity B does quantity A make up? Okay, so we're getting warmer. Scaling, okay. So how about this phrasing, relative size, right? That came up. So what we're going to be working on unpacking over the next few days is this idea of looking at the relative size of a change in one quantity in comparison to a change in another quantity. That's sort of like the underlying notion of many of the things that we're going to be looking at throughout the semester. Okay. Did you get that out of the reading? Okay. So this type of quiz is a good way of like having this type of thing in mind as you're reading is going to help you get more out of it. So if you can ask yourself at the end of a reading, wait, what was the important thing? What was the takeaway? And do this sort of reflective process, you're going to get more out of the homework. Okay? Okay. Feeling good? Yeah? Okay. So let's keep going. Yep. Okay. So we're going to start by talking about quantities and operations to expand on what you read about in your homework. Okay. So if we're talking about a scaled version, a quantity being a scaled version of another quantity, what operation are we looking at? Yes. Multiplication. Okay. So some examples that we could think about for what that might look like. A tree's shadow is 2.8 times as long as the tree is high. How might we represent that? What would be a visual representation? Lines? The bars? The bars. I think they're supposed to appear. Yes, good. Okay, so what might I put onto these bars to convey that a tree's shadow is 2.8 times as long as the tree is high? Let me get some new, yes. So, okay. How does that relate to the bars? So you want the top bar to be the shadow. So this is going to be the shadow. I promise it gets better. And the bottom is going to be the tree's height. So if I'm trying to show this relationship that the tree's shadow is 2.8 times as long as the tree is high, how do I get that message through? Let me get somebody who hasn't said anything yet. Yes, sir.
Use the tree's height as a quantity of 1 as a baseline quantity, and then mark the upper lines 2.8, indicating that it's 2.8 times the 1 unit of a tree height.
Okay, so I could have like here's one copy of the tree's height, here's another, and what's left over here is 0.8, right? Yeah, 0.8. That was a 1, that was a 1. Okay. So what are we doing when we talk about this? Mm-hmm. Okay, so we could imagine this as being a dynamic situation. At the moment, we haven't said anything that suggests that, but that's definitely where we're headed. I'm just thinking more along the lines of a process of scaling, right? So if I wanted to think about what's happening here in terms of multiplication, I can take the tree's height and I scale it up to get the tree's shadow's length. Does that make sense? And by what factor are we scaling up? 2.8. Okay. How would you do the same type of representation for the second example. The number of checkers in 12 rolls is 12 times as large as the number of checkers in one roll. Talk to your neighbor. Or don't. So what should I write? How can we represent this? Somebody who hasn't spoken yet? Yes, sir.
12 lines on the top line.
So you want 12, okay. 1, 2, 3, 4, 5, 6, 7, 8. 11. I think that breaks it into 12, right? Okay. So there's 12 supposedly equally spaced segments on the top bar. Okay, what does that do for me?
All 12 rows, and the bottom one represents one row.
So this is one roll here, and so we're scaling this up to 12 rolls. Up here? Okay. So something that I didn't do on the last one, but is a point of differentiation, is this idea of just because you're multiplying doesn't mean you get bigger visually. I don't want you to be attached to the idea of having multiplication always mean grow, right? Now, this example doesn't actually give you that meaning in a concrete way, but just the practical nature of having to fit this in here at least gives you the idea that that is something to be attuned to. Okay. Oh, I had a second set of bars. Okay, that's okay. All right, what about this now? So this situation is a little bit different. I've got a car traveling at 72 miles per hour for 4.6 hours. Okay. I would like you to use bars to determine how far the car travels in that amount of time. So let's get some labels on the bars so that if anybody's stuck, they can maybe have a chance to think about it. So what can I put on the top bar?
How far, how many hours, like the number of hours traveled.
You want the number of hours on the top bar? Okay. It's going to hurt my brain, but we can do that. Hours. Okay. And on the bottom bar?
The constant rate of speed that's like 2 miles.
You want speed.
Yeah.
How? Okay. So some people are saying distance instead of speed.
Yeah.
Distance works for you?
Yeah.
Okay. Distance. Okay. You want to keep thinking? Or do you know what to do next? Okay, so we know that at the end we're going to travel for 4.6 hours. So if the top bar is representing number of hours traveled, then at the end it should be 4.6, right? So we'll have, where should I, so you said I should split it though? I can. So at the end it's going to be 4.6. What is the bottom bar going to represent if I say the top bar represents 4.6 hours? The distance in 1 hour? The distance in 4.6 hours? Okay, so this is going to be the total distance. This bar is going to represent the answer to my question, right? So how am I going to get from here to there? Yes. When you say the reverse way, do you? Okay. Does that make a difference? What did you do next? Okay, so 1 hour corresponds to 72 miles, right? Now, where should I put the 1 hour marker? Where does that belong on this top bar? Close to this side? It's about a little bit less than a quarter, right? So I've got 1 hour here, and corresponding to 1 hour, you said was 72 miles, right? Now, where should I put that mark on the bottom bar? Can it be anywhere?
Well, to the left of as far left. But that's because you have to be able
What?
to add the other ones in there as we go.
Okay. So,
And if it's a constant rate, there should be spaced out to match that 4.6.
A little less than a quarter.
so a little less than a quarter again, right? Why?
Because you're going 72 miles for every hour. 4.6 hours.
Okay.
That's 4.6 quantities of section 2.
So in order to get from 1 hour to 4.6 hours total, we have to scale up the hours, right? And at the end of this problem, we're going to take our 72 miles, right? That we travel in that 1 hour. Over there. Circular. Take the average. No, I'm just kidding. The midline. Sorry. So what are we doing, right? We're taking the 1 hour and we're scaling it up to 4.6. But when we look at it in a self-contained way, this 1 hour is, slightly less than 1/4 of the total time, right? So when we come down and we compare like this 1 hour increment with the amount of distance traveled, that distance traveled should be slightly less than a quarter of the total distance traveled. Does that make sense? So then what's going to happen? I've got my 1 hour corresponds to 72 miles. There will be a second hour, and that's going to correspond to another 72, and then a third hour, and a fourth hour, and then at the end, 0.6 of an hour, right? And so we'll get that over here. So if I want to compute the total distance, how would I do that? I'm sorry? Add them?
Add your increments of 72, so multiply, that's what he wants to go with that.
Okay, so how many increments of 72 do I have? There are 4.6 increments, right? So 4.6 times 72. Do I need to multiply that out? I mean, I could, or I could leave it as is. What's the benefit of leaving your answer in this format? Were you gonna?
I was going to say, because it just shows your thinking process.
It shows the process, exactly. And that's what we're about here, right, is showing the process. So if you leave your answer like this, I will be just happy as can be.
My brain didn't work this way at all.
Okay.
And is this, would you have considered this to be the only correct answer?
Well, this is the correct answer to the question.
I did arrive to the same answer,
Mm-hmm.
but the way that I used the bars were completely different.
How did you use the bars?
I made the bottom bar just equal to 1 hour at 72 miles. Basically, I just did the 4.6 times 72 in my head. Like, and I tried to show it on the top bar. But I don't know how.
Okay. So there are intermediate steps here, right? And so the thing that is captured by using the bars in this fashion is that when we do this process, we are actually scaling twice, right? We take 1 hour and we scale that up 4.6. So we're scaling time, but we're also scaling distance, the corresponding distance, right? The thing that I don't want to have happen is for you to be unable to separate out the distance and time factors when we discuss the speed. Okay? All right. Now, right. And that is because one of the things that we're going to be focusing on and really driving home is this idea of two quantities that are changing together, okay? So when we discuss a speed, we are really talking about a distance and a time and how those things change in tandem, okay? And so that's the significant takeaway from this conversation. Okay, that's a good question though. All right, moving right along. Maybe. Here we go. Okay, so now we've got the relative size of one quantity in relation to another through the operation of division. So let's try to think about how we can describe this example. So building A is 17 meters tall, building B is 5 meters tall. This translates to building A is 17/5 times as tall as building B. So here's an image to help you think about this. Oh, no, that's not where I wanted to go. Where did it come? There it is. Okay, so the questions that I want to think about at the moment are how can I describe relative size of these two quantities, so the height of building A and the height of building B. How could you describe the relative size? And then we're going to actually break down what the number 17/5 and 3.4 represent. Okay, so take a second to think about how would you describe to somebody the relative size comparison of these two buildings? Can you talk it out with a neighbor? All right, so what do we have? What can we say? Yes, sir.
I can say that 5 A's is as tall as 17 B's.
5 A's is as tall as 17 B's. Okay, that is a true statement. How does that compare to the 17 fifths?
The numerator of the fraction describes how numerator and denominator respectively describe how the quantities behave.
Okay, so let's break that down more. I totally just bombarded you with that question, so good job. Okay, so if I look at this diagram, come on, pen, and I were to highlight just this chunk, right? This is 1 meter in height, right? That's representing 1 meter in height in this diagram. So how many of those make up B? 5, right? So if I were to think of how much is this one block of all of B, you would say it's 1/5, right? So this is 1/5 of B. How many of those are in A? 17. So if we put those together, we get that this is 17 1/5, right? So we're scaling up B to get A. So A is 17 fifths as large as B. Now, another way that we could word that would be to say that we can measure A in units of B. Do you want to take a stab at what that might mean? So take a second to think about, or you just want to go for it? What does it mean to say that I measure A in units of B?
It's saying that how many, essentially, how many buildings of B it would take to make what the size of building A essentially is.
Right. So rather than thinking about these individual components of B, we're going to take the entire B as a unit now. That is now our unit of measurement, and we can now measure A in terms of that unit. Okay. So that's another way that we could think of this as saying A measured in units. It will get better of B. Okay. Is that making sense? So the 3.14 is the result of this division, right? It is the number, the numerical output of this operation. And if we wanted to emphasize how to interpret that number, can somebody give it back to me one more time? What could we say? B goes into A 3.4 times. Okay. And so relative size, the relative size of A in relation to B is 3.4. Okay. Have you ever thought this hard about multiplication and division? It's pretty good, right? This makes me so happy. Okay, so yeah, we're about there. So I think for now we're gonna stop and we will continue. I'm going to have your assignment for Wednesday posted by 1:30. That seems doable. Today is Wednesday. Sorry. No. And so the only other thing that I'm trying to decide how to manage is that we don't have school on Monday, which is cool, but also because half of you have recitation on Mondays. So this creates an inequality that I'm going to have to figure out how to rectify. I will get back to you. So if it's on my mind, I'll think about it. I'll let you know on Friday. Hey, have a good one. No, you can keep those.